question number 4. This question is about group 1 elements. So recall group 1 elements, they lose 1 electron. So it gives 2 observations you could make when a small piece of potassium is added to water. Now, before you start writing answer to this question, it's a good practice to recall the equation for this reaction. So I can say in this case, you'll have solid, where X is any group 1 metal. It will react with water, which is liquid, and will produce XOH plus H2. Now this is gas, this is aqueous. So if you look at this equation, it tells you what will happen. So I can clearly see here gas will be produced. So I can say bubbles of H2. Then I can also see there was a solid on the reactant side, but on the product side there is no more solid. So I can say solid will become smaller, or I can say disappear. Next part says complete the equation for the reaction of potassium with water. You should balance the equation. So I've already got my answer here. All I have to do is write down what you see here. Instead of X, I will use K. So it will be KOH and H2. To balance this equation, I will put 2 here, I will put 2 here, and I'll put 2 here. And this is now my balanced equation. Next part says explain why reactivity of elements changes down group 1. Now recall, what do we mean by the word reactivity? In this case, because we are looking at group 1, we'll say this will be loss of electron. So the reactivity will be based on loss of electron. It's a 4-marker question, so we'll have to have 4 statements. So the first thing I'm going to say is it becomes easier to lose an electron. Now I have to justify this statement. Why does it become easier to lose electrons? This is because more energy shells. As you go down, the atom is getting bigger. Number 2, we can say shielding due to inner energy shells increases. And because of these 2 reasons, I'm now going to say it will be weak force of attraction between nucleus, which is positive, and outer electron, which is negative. Hence it becomes easier for it to lose an electron. Next part of the question says sodium reacts with oxygen to produce the ionic compound sodium oxide. Ionic compound sodium oxide. So in this case there will be transfer of electron. Oxygen is in group 6 element. Group 6 element means it will accept 2 electrons. Draw a dot and cross diagram to show what happens when atom of sodium and oxygen react to produce sodium oxide. So dot and cross diagram. So I'm going to say for sodium, I'm going to use symbol X to show its electrons. For oxygen, I'm going to use dot to show its electrons. So in the first place, you'll have sodium. There are 11 electrons in sodium. So the first shell will have 2. The second shell will have 8. And the third shell will have only 1 electron. When it comes to the oxygen, oxygen has 8 electrons. In the first shell, you will have 2 electrons. In the second shell, you will have 6 electrons. If you recall, the formula for sodium oxide is Na2O. So this means there will be 2 atoms of sodium and 1 oxygen. So I'll put 2 times this. Once I've done this, then I have to show that this electron will go to oxygen, and because there are 2, so in total 2 electrons will go. Then what will happen? This will then change into Na will now have only 10 electrons in total, because each sodium atom has lost 1 electron. There will be a charge of 1 plus, and I'll have to put 2 here because there are 2 of them. On the other hand, I'll have oxygen, and oxygen will now have 8 electrons. Out of these 8 electrons, 2 have come from sodium. They must be shown with a cross. And as a result of this, it has now gained a charge of 2 minus, and an ionic bond will be formed between them two. Next part says, why is oxygen described as being reduced? Oxygen described as being reduced. So reduction means rig, which is reduction is gain. So we can say because it accepted 2 electrons. Next part says, explain why sodium oxide has high melting point. So melting point depends on bonding. Now it's a 3 marker. So you have to write down 3 statements to gain 3 marks on this question. They've already told us that it forms ionic compound. So if you write down sodium oxide is an ionic compound, you're not going to get marked for that. So you'll have to say it has giant ionic lattice. Now what does this mean? This means that the ionic bonds are in all directions. Number 2, I can then say ionic bonds are strong. So this means there are a lot of ionic bonds and they are all very strong. So if they are strong, this means a lot of energy is required to break ionic bonds. Therefore, MP is